Greetings to anyone who's watching this presentation. My name is Ali Iftihar. I'm representing Schools4, and this presentation is on is our midterm project progress presentation. So these are the contents of our presentation. I'll be talking about the problem, the grade, the goals, and the scope of our project, and the data, whereas my teammates will follow up with the rest of the contents. So what is the problem? Why are we doing this project in the first place? The problem lies in the ratio of students not being able to graduate within 4 years, and this is quite high for the US. So we wanted to focus on this problem so that we can come up with solutions that would help lower this dropout rate. It is important to address this problem because it has economic and social consequences, such as the students who do not graduate in time, they have greater chances of being in prison, they are less financially stable, and they have more health problems. So we want to focus on this problem, we're doing this project so that we can focus on this problem and try to come up with solutions for it. As I mentioned before, the goals are to reduce dropout rates or increase graduation rates. And we aim to achieve this by trying to identify students using a certain data set who are identify those students who are at risks. We'll get into the details of this later on, but just to give you an idea of what we're doing. Some of the constraints that we're going to face or we expect to face are that of equity and efficiency. The data that we have, we got that from schools that are located in the region of Southwest Ohio that are associated with MVESC, which is the Muskingum Valley Educational Service Center, and it is for the high school students from 2006 to 2015. So our aim is to work on that data set to identify at-risk students.
So now let's talk about our analytical formulation. Overall, our formulation is that at the beginning of every academic year, for all the students entering 11th grade of the MVESC schools in Southwest Ohio, we want to identify the top 10% of highest risk students who are not likely to graduate from high school on time. And in that way, we want to prioritize for proactive supplementary education and mental health interventions. And our ultimate goal is to increase the overall on-time graduation rate in that area. So each row of our data set is going to represent a student entering 11th grade in a given year. For example, the student with lookup ID 598 will enter 11th grade in 2010. Each cohort is going to be all the students entering 11th grade in that year. So we would use one cohort for training and another one for testing. For example, the 2010 cohort for training and 2012 cohort for testing. Labels. The label is a binary value that indicates whether or not the students graduate on time in the next 2 years. It will be 1 if they do not graduate on time and 0 otherwise. The features on high level is going to be demographics, grades, attendance, number of discipline incidents, number of interventions they received. We noticed that there are many other features we can try to build. For example, we can make use of the address of the students and the address of the schools, and we are still working on building more features. Our model is going to be primarily evaluated on the precision at the top 10%. The reason we choose all of that is, according to the year 2015 data, there are about 2,500 students entering 11th grade in that year. So if the number of students doesn't change much in the years following, we would provide at least about 250 most at-risk students every year, which we think is an appropriate number of students that the MVESC can intervene on. This is our pipeline. First, we use the data pre-process module to read in the raw data, split the data, build the features, and also do the imputations. Then we feed the results into the data loader, where it will transform the data set into the format that the trainer can take on. With the result from the data loader and the model, we input all those into the trainer module where we train our model, and then we pass the model into our evaluation part where we evaluate our model result and output the evaluation metrics we want to look at.
Here, we show our initial results for a two hidden layer neural network with the ReLU nonlinearity trained on a total of 1,548 students entering 11th grade in 2010. Our initial model just comprises of 7 features. These are age, number of days absent in the academic year, and the number of discipline incidents in the academic year, as well as the GPA data of the student in 9th and 10th grade. The network is trained for 100 epochs by stochastic gradient descent using the Adam optimizer and minimizes the binary cross entropy loss. We used a learning rate of 0.001 in our experiment. Our validation set comprises of a total of 2,450 students entering 11th grade in 2012. The task is to predict whether a student will graduate on time within 2 years. The metric that we report is precision at k%. For this particular problem, we are primarily concerned about this metric because given the limited number of interventions which we can propose, we want to be as precise as possible with respect to our predictions. That is, if we indeed are predicting that a particular student should be requiring intervention, it better be the case that they actually do. We report the metric for a variety of values of k. In order to predict the label 1 for a particular student, which means that that particular student requires intervention, we check if the score for the label 1 is greater than a particular threshold value, else we predict 0 for that student. The first plot shows the results on the validation set for values of k ranging from pi to 100 for a fixed threshold value of 0.75. We can observe that as k increases, the precision numbers improve from around 18% to 25%. Next, we vary the threshold values in a relatively higher range of 0.9 to 0.98 and compute the precision metric only on the students that get predicted to have the label 1 with this threshold. The number next to each point on the plot represents the number of students who got predicted with the label 1, that is, that they require intervention. We can observe that as the threshold increases, the number of students predicted decreases quite a lot. Further, as a threshold represents the confidence of our prediction, and now since we are only making predictions corresponding to an extremely high confidence level, we can observe that the precision numbers improve drastically to about 65 to 70%. We know that our initial results are not all that great, and there is indeed a large scope for improvement. For comparison, here are a few baseline metrics which we computed on the same validation set. First of all, of 2,450 students in the validation set, we know that 711 students were indeed marked with the label 1. This is a base rate of 29%. If we were to use a simple baseline, which simply predicts the 10% students with the least GPA in the 10th grade as students who won't be graduating on time, we achieve a precision of 38%. On the other hand, if we were to use a baseline which predicts the 10% students with the most number of absent days in 10th grade as students who won't graduate on time, we achieve a precision of 41.2%. These simple baselines indeed attain very high precision numbers for our particular data set. And our next steps would be to further analyze the data and to extract several other features that possibly involve aggregation and can help the neural network model learn better. We note here that our initial sanity goal was to make the entire end-to-end pipeline work, right from data extraction to a neural network formulation to metric evaluation.
To add more features to our model, we have already observed that having more features increase our model's performance. So there are two sets of features that we plan to add to our model. The first is kind of the raw and derived features from the original schools dataset. So these includes the GPA percentile as opposed to the raw GPA, and days absent percentile or quantile, subject placement categories, which has the value assignments of basic, accelerated, and advanced. Also, disability binary, so whether students have a disability or not, and also whether the students have ever had any discipline incident. And then we also plan to have external features added to our project. These include the ACS block group income data and also the ACS block group education level. So what we will do is that we will associate these external information based on the student's address and add it to our model's input. For model selections, we plan to do hyperparameter search to tune the hyperparameters. Our hyperparameters include learning rate, batch size, hidden dimension, number of hidden layers, and the loss functions. So what we plan to do is that we will use research on the validation set using the precision at K% as our metric. And it will just select the model that gives the highest metric as our final model. Here are our references, and thank you for watching.